Okay, so we're gonna work with a similar problem, but this time we're revolving around the y-axis. Now, when we're working with y-axis revolutions, we have to change everything in terms of y and our perspectives of the problem in like the y world. Because in x, for example, we would use the bounds from like on the x-axis, but now it's the y-axis here. So to start off, we're going to manipulate this equation into x in terms of y. So this would be, you would do that by square rooting both sides. You'd get x equals square root of y. And then, so to find the volume of it, we're going to use a formula. So the bounds now would be 0 to 4, because it's y's. And since there's no space between the region and the axis of rotation, we're going to use the disk method. And to visualize the disk method when you're revolving on the y-axis, we're going to draw, the disk is going to look something like that. And also for x-axis revolutions, we look at the top and bottom function, but for y-axis revolutions, we have to look at what's the right function and what's the left function. So the right, to determine the radius. So for the right function, it will be whatever's on the rightmost, which is this x equals square root of y. Be careful, it's not this function anymore. We're working with this one. So it's going to be this squared, which is r, right? If you see this, that's the radius of that's the radius of the disk. And dy instead of dx, because if we look at here, dy is the height, like pi r squared times h. This is the height of the cylinder. Change in y, right here. Okay? So now we just have an easy integral to solve. You get y, and now we get 1/2 y squared, 0.4 times pi. And 4 squared is 16, 16 over 2 is 8, and 8 minus anything here, that 8 minus 0 is 8, so that would just get that, which is that. Remember, we have to switch our perspectives when we're working with y-axis. And make sure everything's in terms of y. And that's about it for that problem. See you next time.